This first problem here is an example of how to solve for vertical or congruent angles. Now you'll notice from our diagram we have angle GOH and we have angle EOF. Okay, and by definition, these angles are vertical angles. And based on our glossary of angles, we know that vertical angles have the same value or they are congruent. So, question here is asking us to find the measure of EOH. So based on our diagram, my first step, I determined that my angles are equal. And that's what this statement tells me here. Angle EOH is congruent to angle GOF. So to solve for the measure of these angles, we're going to substitute the values of each angle into the equation. Okay, so angle EOF is represented by 5x plus 36. Angle GOH is represented by 11x plus 6. From here, we have a multi-step equation. Now, step number 4, it says distribute if you have to, and then combine like terms. Well, you'll notice that on each side of the equal sign, there's no parentheses to distribute, and there aren't any like terms to add together. So, nothing to do for this particular step. Our next step, and this is a little different from our supplementary and complementary angles, you'll notice that we have variables on both sides of the equal sign. So the first thing I need to do is get all of my x's to the left-hand side of the equal sign. And I do that the same way I would move any numbers to the right side of the equal sign. I'm going to do the opposite. I'm going to add or subtract using my opposite or inverse operation. So to move 11x to the other side of the equal sign, I'm going to subtract 11x from both sides. So this will cancel out, leaving me with just 6 on the right-hand side. And then 5x minus 11x equals 6x. Okay, so now that I've done that, I have what I have. Now I have just my two-step equation. Negative 6x plus 36 equals 6. And these problems we've done before. We're going to add or subtract using our opposite signs to move the positive 36. So I'm going to subtract 36 from both sides. So it will cancel out on the left and move it to the right. And 36 plus a negative 36 is negative 30. And our last step, as always, is to divide by the coefficient in front of x. So I'm going to divide both sides by negative 6. And be careful here because a negative divided by a negative gives me a positive 5. Okay, so we've determined what the value of x is. Now, to find the measure of each angle, or the angle we are here, we're looking for angle EOF. Okay, so angle EOF. Okay, but you notice here I plugged in the value, I took the expression from GOH, which is fine, not a big deal. But why did I do that? Well, I'm going to show you. So the expression for EOH was 5x plus 36. So EOH is 5x plus 36, I think. Let me double check that. Yep, 5x plus 36. So when I substitute in my value of x, which is 5, I'm going to do 5 times 5 plus 36. 5 times 5 is 25 plus 36 equals 61 degrees. Now you'll notice here, GOH, I plugged in also the same value for x, my 5. And you'll notice I also get 36. I'm sorry, 61. My apologies. I get 61. Why is that? Well, they're supposed to be equal. They're vertical. So even though I use the expression for angle GOH instead of EOF, it doesn't matter because vertical angles are congruent. So they always have that same measurement. Okay, let's try next one. All right, so again here, I want to find the measure of QRT. So this is QRT. And again, we're always going to use our diagram to determine what type of angles we're solving for. Sorry about that. The dogs heard somebody walk past the door. We're always going to use the diagram to determine if my angles add to 90 degrees, 180 degrees, or if they're equal. So in this case, we have the two angles we're given are QRT and PRS. And by definition, they're vertical angles, so therefore they are congruent. Okay. So if the angles are congruent, then their algebraic expressions are going to be equal to one another. So my equation to solve is 8x equals 2x plus 72. Now, we don't need to distribute, and there are no like terms to combine on either side of the equal sign. So I just need to get my 2x to the left-hand side of my equal sign. So these cancel out, that's why I subtract. And 8x minus 2x is 6x. And what I have left on the right is 72. And then our last step is always to divide. And we always divide by the number in front of x, that coefficient. So 72 divided by x is 12. So now we can solve for the angle by substituting in the value of x. Now QRT was 2x plus 72. So 2 times 12 plus 72. So this is 24 plus 72. And my mental math, as you guys know, is not that great. So let me grab my calculator. And so 24 plus 72 equals 96 degrees. Okay. So both angles, QRT and PRS, are 96 degrees. All right. I would like you, this one's slightly different, so let me go through this particular example with you. The steps are the same, okay? The diagram is different, okay? With all of our angles, we're always going to use our diagram to determine whether or not my angles add to 90, they add to 180, or if they are equal. Now, in this particular diagram, you notice that there's that little pink circle, that little pink arc for angle FBE and angle EBA. Okay, they both have that little pink arc. Okay, so in a diagram, what that means is that is a shortcut for saying FBE is congruent to angle EBA without having to say that the two angles are congruent. So anytime you see two angles with matching arcs, those angles are going to be congruent. Now, some in our glossary for vertical angles, you see probably something like this, where the top two, okay, so you see how the vertical pair of angles has a single arc, where the horizontal pair has two arcs. That indicates that which angles are congruent to which. Okay. Now, the only other time that we can assume that two angles are congruent to one another is if we see the word bisector. Okay, to bisect something means to cut in half, or to create two smaller congruent parts. Okay, this was similar to the definition of midpoint that we used in our previous unit. Okay, so in this particular case, because FBE and EBA are congruent, that means that BE is a bisector. Okay. Now, how we solve this is exactly the same as the two other examples I just did. The only difference is the diagram. Okay. And the diagram, again, it's the little arcs that tell me those two angles are congruent. But the rest is exactly the same. So you notice here that EBF or FBE, doesn't matter, is represented by 4n minus 13. And ABE or EBA is 2n plus 7. Okay. They're congruent. They're equal. So I set the two expressions equal to each other. While I do not have to distribute or combine like terms, I do have to use our inverse operation to cancel out my n's on the right, to get them over to the left. So I subtract 2n from both sides, which leaves me with 2n minus 13 equals 7. And then I need to get the negative 13 to the right side of the equal sign, so that will cancel. So I add 13 to both sides, and 7 plus 13 is 20. And then our last step is always to divide. So I'm going to divide both sides by 2. So n is going to be equal to 10. Last step is always to substitute in your value of x or n or a, whatever your variable happens to be, to solve for the missing angle that it's asking for. So if we're looking for the measure, and that's what m means measure of angle ABE, so it's going to be 2 times n, which is 10, plus 7. Well, 2 times 10 is 20, and when I add 7, I get 27 degrees. So both angles from my diagram, FBE or EBF and EBA or ABE both have a value of 27 degrees. So this is 20, oops, sorry. So this is, come on. This is 27 degrees and this is 27 degrees. And they are congruent because of those tiny little pink arcs that are there. That tells me those are congruent. The other thing that would tell me that it was congruent is if you saw the word bisector. Okay. Yeah, I do believe the remaining 2 problems left. Try those on your own. We'll go over everything in class when I return. And if you have any questions, be sure to email me or write them down and we'll go over them next time. Problems. But there's one are similar. The last one's a little different. But we can do that one in class together if you can't figure this last one out. That's totally fine.